Let's discuss case study on pair of linear equations in two variables. Let's look at the question which we are discussing. If you look at this overall question, this case study, it seems quite long and with a lot of images. You're having an image of an auto and a taxi. You're having image in the form of a table. There is also a question which has graphs with it. And the question itself is quite long. If this comes in your question paper, it might extend to 2 pages. So in this kind of question, there is a fear which gets generated when you look at the length of the question, that it seems like a tough question. It seems like it'll take too much time to solve. This usually happens if you are not practiced case studies enough or you're not used to these type of questions. But actually, when we look at the details which is given, this is a simple question. Let's see how to filter out the correct information which is required. Over here, you're having a table given. What does this table give you information about? That you will get from the last sentence of this passage. The initial few lines are just to waste your reading time. It gives you some information about the types of transport, and it gives you the factors which affects the travel fares of these kind of transport. But for purpose of solving this question in your exam, reading through this information is not necessary. So the important thing here is auto charges in a city comprises of a fixed charge together with charge for the distance covered. And there are two situations given over here for two cities where distance traveled has been mentioned along with the amount paid. So if you look at city A, you can see when 10 kilometers is traveled, 75 rupees has been paid up. 15 kilometers, 110 rupees has been paid up. For city B, similarly, two situations have been given. Now, if you look at the statements below this table, situation 1 and situation 2, it is just a write-up of whatever is given in the table. Situation 1, city A, for a journey of 10 kilometers, charge paid is 75, journey of 15 kilometers, charge paid is 110. This is the same thing as what we just read out from the table here. Situation 2 also similarly gives the same information as given for city B. Now, if you look at the questions are based out of the information which has been given over here. The first one is asking you to find out the pair of linear equations which represents the situation. You're having two questions which talks about the amount to be paid. You're having a question about graphs represented, and you also need to find out which one has cheaper fare. Now, let's see how we solve these questions individually. And while doing this, we'll only take out the relevant information, which is this, situation 1 and situation 2. That's all that you need to focus on. You need to focus on these statements and answer the questions which follow. First question, refer situation 1. So you need to refer to this first statement here. If the fixed charges of auto rickshaw is X, running charges is Y kilometer per hour, what is the pair of linear equations which represents the situation? See, when you're having a fixed charge and running charges, what's the meaning of this? Fixed charge is a charge that you have to pay the moment you enter an auto and start using it. So it doesn't depend on the distance. It's something that has to be paid no matter what. And the running charges will depend on the kilometers you're traveling for. So running charges are usually charged as certain rupees for each kilometer that is traveled, and it's given here as Y kilometer per hour. Now, let's look at the situation A. When he's traveling 10 kilometers, the charge paid is 75 rupees. You're paying 75 rupees. This 75 rupees would have a fixed component to it, and there would also be a variable charge, which is also called running charge over here. The fixed charge is represented as X, running charge as Y. And since there is 10 kilometers traveled, the total running charge in this 75 rupees would be 10Y. Y was the charge for each kilometer. We're traveling 10 kilometers here. So total running charge becomes 10Y. And since we have that the total price over here is 75 rupees for traveling, you get the equation as x plus 10y is equal to 75. This is one of the equations. Let's look at the next one. Same situation. Again, the fixed charge will be x. The running charge this time would be 15 times y because the distance traveled is 15 kilometers. And this total charge is given as 110. So this way you're getting the two equations which can be formed in situation 1. And that corresponds to option B. This will be our answer for the first question. Let's look at the second question. Again, we refer to the same situation, refer situation 1. A person travels a distance of 50 kilometers. What is the amount that he has to pay? When you're traveling 50 kilometers, as per the logic that we discussed, the amount that has to be paid would be x plus 50y. The fixed charge plus 50 times variable charge. You can see here that in order to get the answer, we need the value of x and the value of y. So we need the equations in order to find values of x and y. We just did that in the previous question. We got the equations as x plus 10y is equal to 75 and x plus 15y is equal to 110. We just need to solve these two to find out the values of x and y and hence get the payment which is required for 50 kilometers. Let's solve this. If this is 1 and this is 2, let me subtract both the equations. I'll subtract 2 minus 1. This way when I do it, I get x minus x which cancels off. 15y minus 10y will become 5y. 110 minus 75. This would turn out to be 35. And this way we get y is equal to 35 divided by 5 or 7. It's 7 rupees per kilometer, which is the variable or running charge. What about the fixed charge x? Substitute this value into any one of the equations. Let me substitute in the first one. We are going to get x plus 10 times 7 is equal to 75, which means x is 75 minus 70 or x is equal to 5. We got the value of y is 7, the value of x is 5. In this case, what becomes the amount to be paid for 50 kilometers? It will be 5 plus 50 times 7, which is 5 plus 350 or 355 rupees. This would be the answer for second question. Let's look at third question now. Now in third question, we need to refer to situation 2. So it's a different set of equations over here. What will a person have to pay for traveling a distance of 30 kilometers? We could again form new set of equations and try and solve this. You're forming a new set of equations, which will be x plus 8y is equal to 91 and x plus 14y is equal to 145. These would be the set of equations to be formed for situation 2 as per logic what we discussed earlier. Fixed charge plus the variable charge 8 times the charge per kilometer. This is equal to the total charge of 91. You get here x plus 14y is equal to 145. Now, in order to find out the amount to be paid for traveling distance of 30 kilometers, all we need to do is solve this for x and y and then find the value of x plus 30y. Let's solve these equations the way we did in the last question. If this is equation 2 and if this is 1, we'll calculate what is 2 minus 1. X and x cancels. 14y minus 8y will become 6y. That is going to be equal to 145 minus 91, which is the same as 54. So we get y is equal to 54 by 6, or we get the variable charge here as 9 rupees per kilometer. How do you calculate the value of x? Substitute this value of 9 in any one equation. Let me substitute in the first equation. We have x is equal to 91 minus 8 times y. So 91 minus 8 times 9, which is 91 minus 72, or this becomes 19. 19 rupees is the fixed charge. What do we need to calculate in this question? How much is paid for traveling a distance of 30 kilometers? So this will become the answer, x plus 30y. Our answer would be 19 plus 30 times 9, or 19 plus 270, which gives us 289 rupees. Our answer for this question is 289. All right. Okay. Now let's go to the next question. Refer situation 2. The graph of lines representing the conditions are. So same situation, which means the equations we are talking about is the same. We have x plus 8y is equal to 91 and x plus 14y is equal to 145. Now in the previous question, when you solve the question 3, we got the solution, the values of x and y as 19 and 9. So here also when we solve, the solution or the coordinates which corresponds would be 19, 9. All you need to do is check where the solution of the equations becomes 19, 9 according to these graphs. If you look at all the options, look at the point of intersection. Here 20, 25. Here it would be 12.5, 0. Here this point is not specifically mentioned. It would be 15, 10. And here the point is 19, 9. So option C is the option where these coordinates are matching. That has got to be the answer. Now, of course, over here, when we are solving the fourth question, here we are getting the answer on the basis that we have solved the two equations. That means assuming you have done the previous question. If you have not done the previous question and if you're doing this question alone, do you need to solve the equations? I'm repeating that. If you have not solved third question, because maybe you are having an option that you only need to solve so many questions from this section. And let's say you chose not to do the third one. Do we need to actually solve the equations over here and find the point of intersection to get the graph? Not necessarily. You could have also done this by substituting y equals 0 in both of the equations. When I substitute y equals 0 in the first one, I get x is equal to 91. When I substitute y equals 0 in the second equation, I get x is equal to 145. What do these represent? These represents points of intersection with the x-axis. That is what these points 91, 0 and 145, 0 shows you when you're substituting y is equal to 0. Which of the graphs matches this? If you look at A, B, and D, look at the x-axis. It's quite clear that these lines will not intersect the x-axis at x equals 91 or x equals 145, whether you're taking options A, option B, or option D. Quite clearly, the answer has to be C by looking at these points of intersection. This is the only one which comes close to the actual values, x equals 91 and x equals 145. This is a way you could have solved this question without actually solving the two equations and finding their point of intersection. Okay, let's look at the next question. The last question asks, out of both the cities, which one has cheaper fare, whether it is city A or city B? If you look at city A, what do you see? For journey of 10 kilometers, charge paid is 75. For journey of 15 kilometers, charge paid is 110. Let's look at city B. For journey of 8 kilometers, the charge paid is 91. And for a charge of 14 kilometers, the charge paid is 145. What is clear from this? Here 8 is less than 10, but the charge 91 is more than 75. 14 is less than 15 over here, the distance traveled over here. And still the charge over here, 145 rupees, is more than 110. Quite clearly, B is more expensive over here, which means the answer over here for which one has cheaper fare would be city A. This is a question which could have been answered without using any linear equation logic. Just by reading the situations, you can understand and answer this question. Okay. So to summarize, these are the answers which we got for the various questions in this case study. As I mentioned, when you have a case study, please do not get worried about the length of the question or the number of images associated with that question. read through the relevant information, scan the data, pick out what is the relevant information and try answering the questions. If you are lacking for time when you're solving for a case study question, glance through the 5 questions which is given in the case study and see whether you can pick any questions which can be answered irrespective of the remaining information, whether you can answer that as a standalone question. Please have a look at that as well. Thank you for watching this video. I will see you in the next lesson. Bye-bye.